that to you. I'm going to keep the calculator in front of the camera and see how best you can see that. Now these are the two equations we have. Negative 0.5 T2 plus 0.87 T3 equal to 0. 0.87 T2 plus 0.5 T3 equal to 417.5. Now write this on a piece of paper so that when I show you that equations are in front of you, because I'm going to take this off. Now the first thing to do is obtain a matrix in your calculator for the coefficients on the left side. What are the coefficients here? The variables are T2 and T3. The coefficients are negative 0.5, 0.87, 0.87, positive 0.5. This is a 2 by 2 matrix. So we are going to make a 2 by 2 matrix on the calculator. Well, let's see if the... Alright. Now this is the TI-83 calculator. What you need to do is the matrix function is on x to the negative 1. You see that? So go second x to the negative 1. That gives you the matrix function. We need to start on here, edit. So go 2 places to the right. There. And we're going to edit a matrix called A. It has been selected. So enter. Alright. Enter. And now we need a 2 by 2 matrix. So what you need to do is type in 2. Now where is 2? Alright, here. Type in 2, enter. 2, enter. And then 2, enter. And the cursor now comes in waiting for the numbers. What are the numbers? The first number is negative. Remember, the negative sign is down here. Negative 0.5. That is the first number. Enter. The next number is 0.87. 0.87. There you are. And enter. Now the second row is 0.87. Enter. And 0.5. So you have now in the calculator a matrix with the coefficients on the left side. Alright, let's now go and make another matrix. How do you go make the matrix? Second x inverse. Now this time you are going to edit a matrix B. So go down once, and that is the matrix we are going to use, and enter. This time the right hand side. What are the numbers on the right hand side? It is 0 and 417.5. That is a 2 by 1 matrix, 2 rows and 1 column. So write 2, enter, 1. That's right. So you got a 2 by 1 matrix. And what are the elements of that? 0. So enter, 0, enter. 417.5, enter. There you are. You got matrix A and matrix B, and what all you need to do is quit this, second quit, and then go and pick matrix A. How do we pick matrix A? Second matrix. This is the matrix menu. And the matrix A is selected there. So enter. Now take the inverse of that. Now which is the inverse? Look at this key. That is the inverse. So if you have a matrix there and if you press that, it will say A inverse. Now multiply that with the matrix B. So go and pick matrix B, second matrix. Pick matrix B, come down to 2 and enter. So we have A inverse B, enter, and you notice here this is the value of the first variable, that is your T2, and this is the value of T3. So the calculator solves the equation for you. Alright, so anytime we have equations like this, you can have equations with 3 variables. And then your left side matrix will be a 3 by 3 matrix. The right side will be a 3 by 1 matrix. So I will not show you this again. I want you to use this method for solving all these kind of equations. Alright? The calculator solved these 2 equations for you. T2 is 360.7 Newton and T3 equal to 207.3 Newton. Now, this is a beautiful problem and you must spend some time solving these kinds of problems. Let's do another one. An object experiences an acceleration of 3 meters per second squared when a certain force F0 acts on it. When its acceleration, now what is its acceleration when the force is doubled? Well, if you know the second law, you can say that directly, because the force that produces the acceleration is directly proportional to the acceleration. Is that right? Well, so when the force, what is the acceleration when the force is doubled? The force is directly proportional to the acceleration means if the force is doubled, the acceleration will also double. If the force is halved, the acceleration will also be halved. That's the meaning there. So it's a very simple problem. B, a second object experiences an acceleration of 9 meters per second squared under the influence of the same force F0. What is the ratio of the masses of the 2 objects? Well, that's a very good one. And C, if 2 objects are now tied together, what will be the acceleration if the same force F0 is used on the combination? Alright, let's start with the data. The applied force is given to be F0. The acceleration that it causes on a mass is A equal to 3 meters per second squared. Mass of the object we don't know, we call it M. Well, therefore we can now write one equation right away. F0 equal to MA. F0 equal to 3M. Is that right? The net force equal to mass times acceleration. Here, the force acting is F0, mass is M, acceleration is 3 meters per second squared. That gives us F0 equal to 3M. That means wherever we use F0, it can now be replaced by 3M. That's a very useful information. Okay, when F equal to 2 F0, let the acceleration be equal to A. Then 2 F0 will be equal to MA. Now, but F0 is 3M. Look at the advantage of that. Wherever we have F0, we can now replace it with 3M. The force is now doubled. 2 F0 acting on the same mass will produce what acceleration? We replace our F0 by 3M. What does that give you? 2 times 3M equal to MA. Now watch this. m and m will cancel from either side. It'll give you the acceleration right away. Acceleration is 6 meters per second squared. Well, that can be even obtained by arguing that if the force is proportional to acceleration, when the force is doubled, the acceleration also is doubled. So the acceleration therefore is 6 meters per second squared. You see how important that you understand these concepts to do the problems. So I spend a lot of time in teaching you these concepts. Try and learn this. B. A second object experiences an acceleration of 9 meters per second squared under the influence of the same force F0. Now tell me, is this second mass greater than or smaller than the first mass? The force F0 acting on the first mass produced an acceleration 3 meters per second squared. The same force acting on a different mass produces what kind of acceleration? 3 times the acceleration. So tell me, is this m prime smaller or bigger than m? If the same force has to produce a bigger acceleration, then that mass has to be smaller. How much smaller? If the acceleration has to be how many times? The acceleration has to become 3 times. Therefore, the mass is 1/3 of the original mass. Now look at the way I'm arguing out. This problem can be done simply by thinking. That means m prime is actually 1/3 of m. Only then will it have an acceleration 9 meters per second squared when the same force is applied on it. Alright, let's go into the proper way. The acceleration is 9 meters per second squared. The same force F0 acting on m prime produces an acceleration of 9 meters per second squared. That means F0 equal to ma, the same equation. F0 equal to ma. M here is m prime, acceleration is 9 meters per second squared. Well, you know that F0 can be replaced by 3m. So, F0 is replaced by 3m. 3m equal to 9m prime, and therefore m divided by m prime is 9/3. You understand that, isn't it? You see, 9m prime equal to 3m, or m prime equal to 1/3 of m. In actual fact, you don't need all these steps to figure it out, that m prime is 1/3 m. You can figure it out quickly by saying that if F0 produces an acceleration of 3 meters per second squared on a mass m, the same force producing an acceleration of 9 meters per second squared on a mass m prime. This m prime, since the acceleration is 3 times the original value, the mass has to be 1/3 of the original mass. So m prime equal to 1/3 m. Okay, what is it that we need to find now?